In this video, I will explain you about the hardware that we have, how the connections are from the relay to the terminals in the cabin, how we how the how we will connect the tester to the cabin, and how we get from the feedback from the cabin and connect to the tester, and we test our programs that we have programmed on the software. But first, let's take a look at the circuit diagram, how everything is in the circuit diagram, and then we will go on the cabin. I will show and explain what every component is doing. So we have one this is the drawing K04. It is the part of the drawings that is related to the relay number 4. The relays are 8 relays from top to bottom. The highest one is 1, then the second from top is 2, and the lowest one is 8. So right now we are checking the relay number 4, the drawing for the relay number 4. Every relay is basically controlling 3 circuit breakers. Here, they are not really circuit breaker. They are just 3 contactors that we are controlling. But they are the ones that are resembling circuit breakers. So first one is modal Mandus Lüliti. Then the second one in here, you can see the lahkulüliti, and the third one is võimsuslüliti. So the ML is used for connecting to the cable to the ground. Sometimes it's needed. LL, lahkulüliti, is used for isolating the cable or feeder. In the power systems, the cables that are used for the transmission of the power are called feeder. Just you should get used to this, because everywhere you see feeder, it means the cable. And then the third connection is for connecting and disconnecting the power, võimsuslüliti, that is used, the main one that is connecting and disconnecting the power. Here you can see how they are connected to the inputs on the relay. We have, this is a relay. They are code for relay P5F30. So the first page is in short and general showing how these contactors are connected. You see this one, 4Q8, is for the Mandus Lüliti, 4Q1. These are the contactors. It's for lahkulüliti, and 4Q0 is for the võimsuslüliti. And this showing, you see this dashed lines are showing how they are connected to which inputs. And if we go lower, then we can see exactly how the normal open, normal close contacts are connected to the digital inputs that are on our relays. So they are connected basically through the terminals. These are the terminals. You see X4 that you see. This is the terminals that the contactor is connected to this terminal, and from the terminal they are connected through another wire to the relay. Let's go to the next. Next line, next page is important to understand. Here we have, you can see that we have our feeder, the relay. This is basically the or power transmission lines that there's very high voltage and high currents there. So we have to scale the current and ampere down using the CTs, current transformator, or voltage transformator. In our map, you see Volu trafo. It's basically current transformator is CT, and then PLT PT is like pinge trafo. So it's the VT. In English is VT. In Estonian, pinge trafo, you see. So these are the ones who, like for example, the CT's job is to scale down the current. If we have here 100 ampere, for example, it will give us, if the ratio of the CT is 100 to 1, it will give us 1 amps. If here is 200 amps, it will give us 2 amps. So we will, like this part, basically this power transmission side, we don't have in the lab. We have only our cabin that has the relay. And this is the circuit breaker, by the way. You can see, this is the drawing, that circuit breaker is this one. In reality, the relay would have to disconnect this one that has very high voltage on it, or connect this one, for example, to the ground, or disconnect it from here. These are the three, like the main transmission lines contacts that we are simulating them by 3 lamps, basically, signal lamps that are installed on the cabin with the same like 4Q1, 4Q2. Those I will show later. So we have the current, like current for line 1, current for line 2, current for line 2, 3, and current for the ground is connected to these terminals that are here. Let me show it in the drawing. You see XV4 is the terminal that if we had like in reality the power lines, the CTs would have to be connected to here. First line here, second line here, third line here, and the fourth line that is for the ground would come here. And the voltages will come here. The voltage line 1, line 2, line 3, and then neutrals, and then sensitive neutral goes here. Let's go back to the drawing. So this first page shows the CTs, how the primary side that we don't have, and like the secondary side that is coming to here. We will simulate the inputs with our tester device. And next page that is showing here to you is the pinge trafos, or VTs, basically, voltage transformators, how they are connected. Actually, in here, there's a small mistake right now in the drawing that it will be fixed. You see this PLT2DN is supposed to come here and connect here. This here should not be connection. This should come here, so that we have a cycle that's coming from here to here, and then from here comes out, goes to the next one. So here there's a drawing mistake. Later it's going to be, in the next revision, it will be fixed. And they are coming to, or again, to the XP4 terminal, and there, like from there they will come here. XP4 terminal, you see, if you see something like this, it means it's bridged. 2 connections are bridged. I can show you in this picture. This is that bridge, for example, that is connecting this terminal and this. So the neutrals, doesn't matter if you connect it here or here, these are connected together. And the voltage lines are like this, connected to here. Here we are connecting using these cables, the banana pistics, to the tester. So let's go forward. So that's how this connection is not always like this, depending on what we are measuring, what kind of functions we want to use for protection of the power line. These connections can be different. They are not always like this. So you just know that because later in the manual, we will see a lot of different types of connections. And then we have here how the contactors are being connected. They are connected using the outputs. These are the digital outputs that are on the relay. This is our relay, P5F30 again. These are the outputs that we will control in the logic of our program in the relay. And using them, we will connect or disconnect this for Q0, for Q1, for Q2. These are those terminals, the three main terminals. Võimsuslüliti, I think lahkulüliti and manduslüliti, or other way, yeah. So these are, here you can see the contact's name. Here also there is a small mistake. This is A3, so they should be copied. This is A3, here is also A3. This kind of mistakes are common, usually happening in the circuit diagrams in practice. That's why we have the next revision coming. Soon it will be ready and these small problems are solved there. And for getting feedback from the relay, we are basically using this contact. This contact is free here. You can see it is not connected to anywhere. So the X for 108 and X for 17, these are two contacts that we will use for getting the feedback. Anytime that the fault happens and the relay acts, does like tripping, this connection that is DO4, this one, right, usually it's normal open, it will be connected. So and we have to connect these two sides to the tester feedback, and when this is connected, the tester will detect that the trip has happened, and later you will learn how we measure the performance of our program. Basically, we can measure how much it took for our relay to trip basically and disconnect or change the status of these contactors. So this all of the outputs we write in our program which one should be operating. So usually we will write that when trip happens, we have to say that the digital output 4 also has to turn the status to the normal, to the close, so that the relay gets the feedback, the tester gets the feedback. So the outputs you can see here, then these are the the lights that are resembling those. These are installed on the door. You can see those lights that they have two status. One is green and the one is red. So those will indicate what is their, this green and red will indicate what is their status. And you see for Q0 is controlled by the terminal, what was this? For Q0, this one, võimsuslüliti is this one. And 8 is manduslüliti. So when the terminal there is activated, this one will become red or green, depending on what is the status. 8 was manduslüliti, so this one, each of them are showing which of the switches have been activated. And this is the next one. So this was all about all the contacts that you need to know. And I will show you in here, there is those terminals. Like already I showed you, these are for the current. This is very important to remember. Current should be connected to here correctly. And the voltage should be connected to here so that we can protect our tester device and protect our relays also. So be careful when you are connecting those. Ask me or other teachers for controlling it before you put power on. These are the contactor relays that are activating and the different types of them. You can see different places. But here we have that you have to power them on from on the wires. You can see the information of the wire cable, wire and the contact address also. So if you see, for example, this is for the connection 14. Here also on the pins you can see A1, A2, like A3 was up there or here. These are the contact numbers that you should follow when you are like connecting. I think A3 was down here. So those terminals you will not open or close them, but here is very important side that you will work with. This is the terminal that you will get the feedback from. You remember pin 17 and 108 that we have to get feedback from. They were here. You see X4 pin 17, terminal 17, X4 terminal 108. But as you can see, this terminal 108 is connected to the L plus, so the I think it's 24 volt that is connected. So we have to disconnect this contact, and we connect this pin, the 108 terminal to our tester, the positive of the tester. But for the before that, we have to disconnect this here. I will show you how it's done on the terminal. And the 17 is free. It's not connected anywhere. So we just connect our wire to here and feedback wire, the minus side to here, and we connect to the tester. The 108, it's already connected to the plus, so we have to disconnect it. On the terminal, we have the possibility. So remember terminal 17, terminal 108. Let's go back to the picture. Terminal 17 is this one, and you see this is the like the cable that we have connected, and this is connected to the minus in the feedback of the tester device. So 17 is simple. It was free. It's connected to here. But 100. These terminals are a little tricky also. They have two sets of the connections. So they have two floors basically. One is this higher one. The orange connections are together, and the green ones are together. You see the back ones, these green ones. This green, for example, is connecting to this one that is here. And this one, orange one, is connecting to here. So we have here the tester device. The power is connected. You see this terminal is opened. This is for the 108, so that I am disconnecting it from the plus side, from the positive side. The positive is connected from down there to that. So when I open it, these sides are not anymore connected to that. So the cable that is going from here to the relay is, I'm just connecting to that directly. Basically, I'm doing like this. That I disconnected the terminal from here, X408. I disconnected that from there, and I connected this, the wire that was coming from the relay. I connected it to this black wire that is here. So this is coming, the wire that was coming here from the relay. I connect this directly to that, and took it to the feeder, and I have to take this 108 from here so that the plus that is coming from down is not connecting to that. So the numbering of those, you see the higher number, these are a little higher than this. These are the terminal numbers for the orange connections. So And the back ones, the green, this one's 101 through 207, is the connections for the green connections, which are in the back. So terminal 1 is basically this orange that you see X41. You can see here, and here is also X41. There's the label on the wires that are connected to this terminal. These are connected together, and if I want to disconnect them for any reason, I have to like open this orange part. These are new terminals that give you the possibility to open them. So if you take off the green one, you're disabling basically the terminal 101. And if you take the orange one, you're disabling the terminal number 1. So I hope it's clear. And this is the fuse that when you are like doing anything around here, better to disconnect first. It should be green. Right now it's not connected. This is the fuse for this part. You disconnect this, all of the power from this part will be disconnected. And every relay has one miniature switch like that, miniature like protective fuse. So you put it green and then do what you have to do here. And when it's ready, then you connect this back.